So today we're going to move on to radicals or roots. So we need to first factor the number under the radical, and we're looking for prime numbers. So for example, 2, 3, 5, and 7. Alright, so I'm going to factor this. So 20 is the same as 2 times 10. There's a prime number, I stop there. So 10 is 2 times 5. So 2 is a prime number, so I stop. 5 is also a prime number, so I stop. Once I get to all prime numbers, I have fully factored this. So then step 2 says circle groups of 2 for a square root or 3 for a cube root. So when there's no number out front, there's an invisible 2, which means I'm looking for groups of 2. So 1, 2, no other groups. For each group, one copy comes outside. So there's 1, 2, so 1, 2 is outside. And then whatever is not in a group stays inside. And then we simplify. So 2 to the first is just 2. Alright, so moving on. So again, we're going to factor this. So 2 doesn't go into 81, but 3 does. I can divide 27 into 3 and 9, and then 9 into 3 and 3. Alright, so I have all prime numbers, so I'm done factoring. I'm going to look, I see a 3, which means I'm looking for groups of 3. 1, 2, 3. 1, no other group. Alright, so one group of 3, and then inside is still going to be this leftover 3. Alright, so that's my answer for that one. Alright, so we're going to simplify this. This simplifies to 2 and 288. 2 and 144. 2 and 72. But we can also pick numbers that are bigger than 2 and 3. So for example, 72 divides into 8 and 9. Now you could keep dividing by 2, it's just going to be super long. So 8 splits into 2 and 4, and then that splits into 2 and 2. And you can see I'm already running out of room, so it might be better to use bigger numbers. Alright, so now I'm at all prime numbers. So I'm going to group, and I'm going to group by 3. 1, 2, 3. 1, 2, 3. 1, 2. So there's not enough to make a group, but I have 2 groups of 2, and then inside I have 2 3s. And then I'm going to simplify this. So 2 squared is 4, 3 squared is 9. Alright, so here's an example where I might use some bigger numbers, but we're going to start small. So 2 and 2520. And then here, this splits into 10 and 252. Okay, so that part's done. And then 252 splits into 2 and 126. 2 and 63. 7 and 9. And then 3 and 3. Alright, so now I'm going to look. There's no number, so that's my invisible 2. And so let's see, 1, 2. 1, 2. 1, 2. Alright, so 2 groups of 2. And a group of 3. And then inside we have, let's see, a 5 and a 7. So then I'm going to simplify this, and this gives me 12 times the square root of 35. Alright, so now let's look to see what it would look like with letters. So I'm going to rewrite this so that we can more easily see it. And then I'm going to write out how many copies I have. But first I want to take a look at what I'm grouping by. So I'm going to group by 3s. So I'm going to organize it into 3 spaces so that I can easily group it when I have bigger exponents. So I have 3 copies of A, so A, A, A. Then I'm looking for groups of 3, 1, 2, 3. So there's one group of A's and none left over, so we don't need the square root. So then we just simplify to A. So now let's take a look at this last one. So I'm going to look for square roots or groups of 2. I have 3 x's, so 1, 2, and then you can see this is how I'm going to organize them because I'm looking for groups of 2. And then 4 a's. Alright, so here's one group, one group, one group. Now I can simplify my radical. So I have 2 groups of a, so a to the 2 or a squared. I have one group of x, and then inside I don't have any a's left over, but I do have an x. And then again, we don't need those ones, so I'm going to get rid of them. And there's my final answer.